Hello, everyone. Thanks for having me back. So I'm just cleaning up my screen. There's like a lot of Zoom overlays. I can barely see it. Okay. I'll assume everyone can see my screen. If not, just give me a nudge. So yeah, we'll be talking about service monitoring and alerting. And we'll dive into that straight away. As you could see earlier, there'll be like a little bit of live coding, but there's also a bunch of slides to go a little bit into detail. Hello, yeah, I'm Jelmer, and I'm a senior site reliability engineer. I do some stuff for the HTTP, like the HashiCorp cloud platform, where I'm helping out with reliability issues. I've got like several years of experience with like distributed systems and building like highly reliable services that connect to each other, helping like reliability in that aspect, and building developer tooling. So today we'll cover a few topics. So just there we go. First, we'll like dive into something that like some acronyms that you've probably heard before, but might not fully like know what they are. There's so many acronyms these days, so we'll go over that and like figure out what those actually mean. Then we'll dive into error budgets a little bit and what that means together with burn rates. Then we'll dive into monitoring and alerting as well, what the difference is and when to use what. And then we'll get a demo. I'm hoping my demo is going fine, but we'll see. We'll find out in a bit. And then if there's any questions, feel free to ask, and I'll be around afterwards as well. So feel free to shout out. I've also like at the end added a bunch more reading material. I'll upload these slides once we're done, and then I'll post a link in the Slack channel. So service level what? As I mentioned, we have a lot of acronyms. So there's like SLI, SLO, SLA, and that are like get thrown around a lot when we talk about observability and monitoring and alerting. So to like set the tone for this, we'll figure out what they actually mean and like make sure we're all on the same page on that. So we have service level indicator, which is basically strictly defined measurement of some part of the system. We'll look into that later on, like an example of that. But what we're saying here is like we want to measure the specific part of the system. You then can figure out how you're going to define that, what that actually means. But the indicator is okay. I want to. This is the measurement I want to think about. This is the measurement I care about. And then you have the objective, and that is where you say, okay, this measurement I have, like for our service, this should be within this range, or this should be this amount. Like if you have an error rate, for example, which is the indicator, but then your objective can be like, oh, we want to have the error rate below 0.5%, right? That's the objective. What's the target we want to reach for this defined measurements? And then the agreement is what are the consequences if we don't meet these targets? So I went over this a little bit already. And I'm way ahead of my schedule, so this is going to be interesting. So some examples of service level indicators is like request latency, success rate, durability. So durability is actually an interesting one, and I actually like I'm not going to go like the demo doesn't show durability, but this is like if you think of a database system, if you do a write to a system, or even like other systems have, like it's more like correctness as well. You can compare the two. But if you do a write to a database system, you want to make sure that like you can read that from another replica. That's what we mean with durability. And then throughput. So how many requests are we processing per minute? So these are indicators, right? So the objectives then are, okay, I have an availability indicator, so my service is running okay. And I want to have 99.9% availability, which means I can only have 0.1% downtime, and we'll define that later on, or we'll figure out later on how we can work with that. One important thing, or some other examples like for 90% of our requests, so these are percentiles, 90% of the requests should go under 100 milliseconds. So this is like the latency indicator. Then 95% of the requests should be under 250 milliseconds, and so on. So you can, like, per indicator, you can actually have different SLOs as well. So you can actually say, okay, this is an indicator, and then I have different SLOs per that indicator. So you can have like more strict things as well. And especially like with latency, if you think about percentiles, that's actually quite interesting, because you're always going to have like slower requests. So you want to like make sure that is fine, that you count for that, and that you don't go over that. But then you also want to make sure that like the majority of your requests like serve within that reach. One thing to note here is that you should never really aim for 100% availability. And we'll see later on, we're actually, I hope I added a slide, but we'll actually look into some nines. Oh, actually, I didn't add a slide. I added a note for it. But if you think about, for example, 99.9% availability, that actually means that you have 8 hours or 8.7 hours of downtime over the entire year, which is quite like strict already. If you think about like a full year, less than 9 hours of downtime. But if you go to 99.99% availability, you have less than an hour of like downtime that you can like tolerate. So it's important to think about that. Like 100% downtime, we can never like really achieve that. Especially like if you then the next step, if you link that to SLAs, you'll get in trouble. One other thing to like note about this is like these don't necessarily have to be like perfect. Like when you start implementing these measurements and these principles, they don't have to be perfect. You can redefine those. You can like a lot of times you use policies, and I have in the reading material, there's like links to this, but you would define policies to say, okay, these are our policies that we have around this, and then you just iterate on that. And if you add that to your service, like if you have version control, you can just like have versioning now. You see like, oh, actually this SLO is way too strict for what we need for this to be, or it's too loose. We want to change that. So you can reiterate that, and just keep that in mind as well. And then the next level is service level agreements. As I mentioned, that's a contract that you actually link to an SLO. So if you say, okay, we have this SLO where we need 99.9% availability. So our SLA is going to be, okay, if it's anywhere between 99.5 and 99.9, and we're gonna like credit you back 10% of that for that duration. So like it could be like an SLO for like a quarter, right? So 10% of the money spent with us, we're going to credit you back if the availability drops below 99.9. And again, you can have tiers in that, and like different levels of that. One important thing here is that you actually always want to have like internal SLOs versus external SLOs. So you can imagine if your internal SLO is 99.9% and your external SLO is 99.9%. The moment you hit your internal one, you already hit your external one, so you don't really have any time to react to that, right? And especially like if you think about it later, I don't know if you hear this, but my dog is drinking, so she might be a bit noisy. But yeah, so you want to make sure that your internal ones are a little bit more strict than your external ones, so you have a little bit of leeway to go around that, so you don't have to like you're not immediately penalized when you hit that the first SLO basically. Error budgets. So an interesting aspect of like the whole SRE view on SLOs and stuff, and all of this actually comes out of the SRE book. Again, link at the end. But this is the concept of error budgets. So it's basically a measurement to say, okay, so we specify that we will never have 100% availability, or we're never going to have an SLO that's 100%. So we're always going to have something less than that. But how much time between, or how much of the percentages that we are allowed to have versus the 100% are we spending, right? And error budgets are exactly that. So if you say, oh, we have a 99.5% availability SLO, then that 0.5% is actually 100% of your error budget. So that 0.5% is the amount of errors that you can have, that you're allowed to have in that time period. So if you think about that, if you have 1,000 requests coming in, your time frame for your SLO, 5%, or like 5 requests rather, of those 1,000 requests are your error budget. So per error that you get 20% off like your error budget, which is in this case like quite a bit, but obviously like in general you'll probably have a little bit more traffic, because again, like SLOs are generally measured over like a longer period, like over like a month or a quarter, or even like it doesn't really make sense to have an SLO for like 1 minute. And then error budgets, like you have this number now, and you can be like, okay, so we're actually like spending this error budget, and if you're spending this as a very low rate, so for example, at the end of the quarter, you still have like 99% of your error budget because you barely had any issues, and then you can know like, okay, you actually did very well, and like we can improve a little bit, we can add more features, we can like be a little bit more aggressive, like pushing changes and like trying things out, right? But this becomes particularly interesting when you have a platform or service that is a little bit unstable, where you can say, okay, we actually like within, like if you have an SLO of 3 months, within the first 2 weeks, we've already spent 90% of our error budget. Then you know, like, okay, we got to be very careful because, well, we still have so much time to go, and we already spent so much of this budget. So we got to figure out a way to like to make sure we don't go over, or we're going to hit that SLA, and there's going to be consequences to this, right? And this is like error budgets help a lot with that, because they like what I mentioned before with the policies is they're predefined, and then you can say, okay, when we hit this error budget, or when we hit this amount of our error budget, we're actually going to start tackling these issues, right? So if we hit, for example, if we only have 30% left over error budget, we're going to stop doing code deploys and actually fixing the issues. This is all dependent on your situation as well, right? But these could also be predefined policies that you have in place. And that helps a lot with like communication within the company, where you can say, okay, well, we predefine this, so, and we have the measurement that we actually can back this up, that we are having an unstable platform. So we actually have to spend time on actually fixing the underlying issues now, because there's always like a little bit of tension between like the SRE teams, or like the product teams and the engineering teams of like, well, product wants to like get features out, engineering wants to like spend more time on like cleaning up their code, but SRE is like, oh, you got to make this stable, right? And like having this error budget like basically gives you that number, and it's like, okay, we agreed on these things up front, we're seeing that this is being hit now, so we actually have to like implement that, and take that with a grain of salt, because again, like what I mentioned with SLOs as well, and you can like redefine those, right? Yeah, so like this is like to enforce like SLOs won't be met all the time, and error budgets are like there to help you out, to guide you towards, okay, we have to intervene with their service, or this is fine. Like if you're like halfway through your SLO period, and you have like you've only spent 5% of your error budget, you're fine. You kind of want to actually spend 100% of that error budget in that time, because that means you're like going at a good rate. And that actually like comes into burn rate, which we'll talk into a bit. So yeah, I kind of went over this already, but this is a practical example. So for example, if our SLO is like 99.9% success rate for the past 7 days, and same for the past 30 days, if we have 1,000 or 1 million requests for the past 7 days, our SLO is like not like we haven't reached, or like we haven't reached the SLO. So we've actually overspent our budget. And for the 30-day period, well, we didn't really get that many more errors, so our SLO is actually fine. So you can see for the 7-day period, we actually have a negative budget. So like we're not doing very well in that period. But for our 30th day, we're actually doing fine. So how can you actually like start thinking about that, right? And this is where I think this is the next slide as well. This is where monitoring and alerting come in like quite interestingly, because sometimes you can be like I've seen a lot of systems where the moment an error occurs, you get paged and people get woken up, and it's like, well, it doesn't really matter as long as we're not going to overspend our budget within this time frame. We're actually fine. We can tolerate some failure, right? Sure, like if it's a spike and all of a sudden like you spend your entire budget, we're gonna want to like think about that. Or like we're going to want to intervene with that. And in a bit, I'll show you some alerting things that will actually go deep into that. I'm not going to fully explain that because there's like a lot of stuff to it. I've linked documentation to it. But yeah, like this is where all of this comes from. It's like thinking about, okay, we do have this number of requests that we are tolerated to fail. So why wake someone up in the middle of the night to fix this issue if it's not going to go over this number, right? And that's where error budgets come in very nicely. So then we're moving on to monitoring and alerting. So you've defined all those things now. So you know what those things that you care about are. You know what the values are that you want to reach. But how are you actually going to like know that you're like meeting those expectations? Oh, sorry, I just got a PagerDuty alert. Just a sec. Oh, it's just a change. It's fine. So, sorry, I lost my train of thought now. So yeah, how are you actually knowing that you're meeting the expectations? And like, how do you know that like your system is doing fine, right? This is where monitoring and alerting comes into place. So monitoring is basically the collecting, like processing, aggregating, and displaying all the data that you have about that system, and just visualizing it and like looking at it. So this could be like latencies, error rates, number of servers, could be logs, could be events, could be like a bunch of things that you do in monitoring. And you can like build dashboards, which we'll look into it a bit. That's the monitoring part of things. And then the alerting side of things is, okay, an event is happening, and now we need to like notify a human for this. And that notification is going to another system. And those notifications, like that doesn't necessarily have to be a page, like wake you up in the middle of the night page. And that could be a Jira ticket, a GitHub issue, but it could also be a page. Like, for example, like what I mentioned earlier, if we're seeing that, yeah, sure, we have errors, but you know what? It's actually not like, it's not going to spend our error budget like that drastically. Like it's only going to like, if this issue keeps going for another like 5 days, sure, then we're going to start happening, like then we're going to start seeing some issues. Like then our error budget is going to like be consumed by the end of this period. Like we're going to have a negative error budget. So like it's like a forecast of like, okay, if this amount of errors keeps happening, we're going to be in trouble based on our SLOs. But it's not immediate. So in that case, you can be like, okay, I'm just going to make a Jira ticket. Like someone else can look at this once they're awake, right? So this is why you have like multiple on-call rotations, and like you can say like, okay, you're going to look at this during the day. But if you're seeing like an issue that is like, okay, within the next hour, we're going to spend like 30% of our error budget, well, you better wake someone up for that, right? And this is where alerting comes into play, and like where you can have multiple, I think I actually wrote this down. Yes, I think so. Where you can have multiple types or setups for your alerting. So monitoring, you use that for analyzing long-term trends, historical or experimental comparisons. So you can say, okay, we have this new feature. Is it actually performing better to our like historical data? Or like if you do canary deploys, is it actually it's feature A, or this feature that we deployed on like these servers is actually performing better than the stuff that other people are using? You can like use that for comparison. Use that debugging. Think about like logs and stuff. Like if you think about distributed traces, you use that to like go into your system, then you link that to logs and all of that. Like all of that helps with debugging issues. Dashboards as well. So you can like make everything like visualize everything and like look at pretty things. I'm not sure why I put alerting on monitoring. That should be a different slide, but here we are. So I've categorized. So there's like in the resources I linked later on, you'll see more categories under this. But I've categorized 3 main ones that I think are important to look at or important to think about. And these are the 3 that I'm going to try and demonstrate today. I've been playing around with the numbers a little bit. It's a little bit hard in such a short time period of running the test to actually do it. You need like a lot of data. So we'll see how that goes. But the first way you can start alerting is, okay, my error rate is over this threshold or equals this threshold that we set for this SLO, right? Like we see that immediately, like within this minute, out of 1,000 requests, 5 are failing. Okay, fire an alarm, wake someone up, and they'll figure it out, right? But then we can also say, okay, we're going to fire this alarm for like, or we're going to monitor this alarm, and we're going to evaluate this for like an hour period. If this keeps happening for an hour, if this like if this error rate is going over this threshold that we set for an hour, then we're going to wake someone up. So the issue with the first one is that you actually like wake up people like all raw. Like error spikes can happen. Like you can have a network connectivity issue within your cluster, and like you can all of a sudden you can have like a little blimp in your setup, especially if you have like a lot of things going on. A little blimp, and that could wake up an engineer, but like that could be like a database failover that automatically restores, and you're like, okay, we don't really care. So this is where alert durations then like help a little bit, because you're like, okay, does this persist? Does this issue like keep happening for a longer period of time? Does this actually like, this is an ongoing issue, right? Instead of just like very reactive. But the issue with that is that you still like, well, first of all, it's delayed. Like what number do you actually choose for like that duration? But you're also not really like thinking about like, well, is this amount of errors like is actually like going to affect our longer term SLO rate or SLO threshold, right? Because if you think about, oh, we have an SLO for like that, or an SLA that's like measured over 90 days, well, then you have to think about, well, we should actually measure that over 90 days. But 90 days for an alert is just ridiculous. So you start thinking about, okay, how can we do that? And this is where burn rates come into play, really. It's quite complex, as we'll see in a bit, but it's also quite precise, and it tolerates a lot. And like the reset duration is quite interesting. So like if an alert fires and then it stops firing, but then it fires again, some of the 2 above, like they might not catch that, and then they'll refire, or they won't like with the alert duration. If you have like things that run every hour or something, or like every 10 minutes there's like a massive spike, and that's like a persistent issue, well, the alert duration isn't really going to capture that, because that's not going on for an entire hour, right? But for the error rate, you're going to keep being paged constantly, but you might also not be paged if the error rate is not high enough, but a burn rate could capture that. So if your burn rate is high enough, where it says like, okay, the errors that we're generating, how am I actually doing for time? I should probably dive into this demo. The amount of errors that we're generating is actually burning through that error budget. So now alert someone. So for the sake of time, I'm just going to start demoing this. Oh, that's not what I want. So this is a simple application. I can actually show you the application. Like it's literally, this is the application. The rest is all set up. Actually, is this clear? My terminal? I actually don't know. Let's see if someone could just, I don't have Zoom open at the moment.
Yeah,
so if someone, cool.
It's good.
So yeah, this is a very simple application where it just like parses like a header. It says like, oh, give me the error rate, and it converts that to a float, and then we get like the error rate, and then if we're within that error rate, we're gonna like generates a random number, and if we're within that, we're gonna throw an error, and if not, we're happy. This is how I'm gonna do my load tests. So this is how we're gonna figure out how stable the system is. But first of all, like we'll look at, so this is Prometheus, by the way. I've chosen Prometheus because I actually really like Prometheus. I'm not going to dive into how to run a highly available like Prometheus setup and like Grafana and all of that. We can talk about that separately. I'm like super happy to talk about all these things, but we just don't have enough time to dive into that. It's probably like 3 hours I can talk about that on its own. But what we have here is I define like a lot of like records basically, where we say, okay, so in Prometheus you can have like labels. One of the labels is job. So what we're gonna do here for every job that I have running, so my application is a specific job, calculate this error per request at a rate of 1 minute. So this is not a record in my Prometheus setup where we have the error count for my, so all the requests, so I can actually show you that. So this is like a global thing. I'm going to push this repo as well, so you can look at it later. But this is a recording rule where we say, okay, we're going to record this. And the errors are basically all the HTTP requests that have a 500 code. And then the total count is all the HTTP requests where the status code is, well, everything, like 200s to 500s, well, including 500s, right? So what we want to have here is the error rate request, or the error request, right? So what we're going to do is we're going to take the error counts for a 1 minute period. We're going to divide that by all the requests over 1 minute period. And we do that for like a bunch of rates, right? So like these are all time things that we want to look at. Like we want to look at 1 minute, 5 minutes, 10 minutes. Like in our demo, actually not looking at all of these. I just added them. I don't really know why. But then the interesting thing that we're going to start looking at is, okay, so actually maybe I'll pull this up a little bit just for clarity. But this one is our SLO, right? And I don't know why I defined this way, but what you would have is your SLO is computers. Your SLO is basically 99.5, right? And that's our SLO for service. We define that with the service. So this is the whole thing of like with Prometheus, you can link all those things next to your service, because you can lazy load these definitions ad hoc or like dynamically on your Prometheus instances, or you can use like something like Cortex to like do fancy things. But this is why I'm not going to go dive into like the whole deployment. It depends on your situation. But this is how you can define that within the service. So you can say, oh, actually, I care about this specific error budget, and this is going to be labeled for this specific service with a job label as well, which is going to be then the demo app. So my SLO for this app is 99.5, right? And then I care about a few specific error budgets. So I'm going to care about like the remaining error budget I have for 1 day, and I use that for day-to-day work. Like, did we have a spike today? Should I be like my on-call person, like look into this probably? Do we have a longer term issue? The 7-day, 30-day, 90-day, right? And these are just good to define, where you can like just have these things available. Like, and generally you mostly care about your actual SLO, long-term one that you're going to link to your SLA, which is probably going to be the longer term one. But I like to include like the shorter ones as well, and we'll see why in a bit once I show you the dashboard. Actually hope I'm still running this. Yes, okay. Sorry, I'm just spinning up some errors in my app. So we have some extra data. There we go. I've been running like 200 requests, like successful requests the whole time. So we have these SLOs now, but now we want to alert on that. So if you look here, this is so I've defined 4 alerts, the demo simple threshold, which we talked about earlier, which is just basically saying, okay, my error request rate for 1 minute is over this SLO thing that I have, fire away. Then the duration alert is the same query, but this is the important part. Is this happening for 1 hour? I'm just going to show you that real quick. And it's not firing yet because, well, I have this very low target. Let's make this 30%. This is going to need a minute, so it's evaluating this every minute. But as you can see now, I get a lot of errors here. And in the meantime, I'm going to show this dashboard that I built. And again, you can define all of this next to your application. So in the repository, we'll see I have, like, it's not very pretty. It's a bunch of JSON, but trick of the trade, what you can do is you can just do this. You make it yourself, and then you just get the JSON model, and you just save it, and then you just have your CI system upload it when you need to. And that is how you make GitOps dashboards, basically. But what you can see here is the RPM. So we see you have a bunch of requests here. And this is when I started this whole new error thing. You can see it going up, right? But what I've also included here, and I think I should probably zoom out of it. Why not working? Oh, interesting. Let's do this. So what we can see here is that our 1 minute error rate went up like a massive amount, right? Like 15%. That is about right, because actually I'm running 2 instances of like my load testing. One is like 0%, the other is like 30%. So that makes sense. But then our 5 minute one is actually going up slower, right? So our 5 minute evaluation is going up slower, and our 30 minute is going up even way slower. So that's what this dashboard is basically. So just the evaluation periods. So if you look at this now, you can see the simple threshold is already firing. Like, it's like, okay, this is a massive issue. Like, go do something with it. But then this duration alert is like, oh, don't do anything. Like, we need to evaluate this for an hour. And as you can see, like, oh, like, this is going to take a while before it actually gets up, right? So yeah, like, it's pending because the alert is actually triggered. So it's over the 0.005 number. So if you actually look at this, so it's 0.14 here, but it's not firing yet because, well, we're still not in that 1 hour period. Oh, the value was here as well. Anyway, and this one isn't firing either yet, which is quite interesting. But that is because I actually set for demo purposes, set the rate to 1 here, and the rate to 5. Oh no, this is 5 as well. I played around with the rates, which makes it not sync up anymore. But I'm just trying to like show you the different like alerting systems, basically. And this one is firing because, well, for 30-day or 3-day consumption, we're actually going over our error budget. Like, within 3 days, we're actually going to hit that burn rate quite a bit. But this is like just generating a ticket. So within the system, you can like say, oh, go page someone and go make a ticket. So not sure why this is still not firing, because 30% is quite a bit. As you can see, these more complex ones are hard to configure. But let's have a look at them. So what we're basically saying is, if the error rate for 1 hour is over the specific value, and this calculation is in the book that I've linked as well. But what we're basically saying is, within this time period, it needs to go to 0 after it. That's the 14.4. There's like a whole formula to calculate it. so within the hour, if we're going to exhaust this error budget, and if we're also going to do that within the minute. So I'm not sure why we're still not exhausting that within the hour, because I'm actually hitting it quite hard with a lot of errors. So I'm confused. Probably have to retest this, but this should be firing at this point. Or so like we're seeing, is this issue like actually going to affect us in the long term, and is this actually active, right? Or is this like longer term, like is this going to affect us over the 60 minutes, but is this also active over the past 30 minutes? So like it could be that you have spikes which are not covered with this 1 minute thing, but you could also have it where like if it spikes, it might not like be triggered because it's not going to hit this one hour thing for the 1 minute. But that way you can like have a different time window and like recalculate it based on like different time windows and stuff. And this is where it gets very complex, because like then you have to like think about, okay, what are these values that I want to put in? And I'm still surprised this is not firing yet. Let's make it 100. Let's see if this is going to fire now. Interesting. Well, that wasn't supposed to happen. Probably because I kept the whole thing running, which I probably shouldn't have done. But let's do this. So yes, okay. So yeah, this is the alerting setup, and something must be wrong here. Oh, this might not be. All right, okay, something is not correct in my query because there's no results for it. I might have made a typo somewhere. I'll try and fix that up, and once I push the repo, so you can look at it in more detail, because
it's the demo gremlins. They always hit.
yeah, exactly. So I'm not entirely sure what is going on. I tested this yesterday, and then I changed. And yesterday it worked, and then I changed a bunch, and now it's obviously not working anymore. Anyway, so what we're going to see here is so now I'm going to like fully consume. All my requests are going to go up, and I know I'm fully over time, so you can tell me when I need to stop off as well. But okay, this is not going to fire, right? So if I do this again, if I have full 100% success rates, what's going to happen? This one is actually going to become active. This one is never going to have fired. This one was supposed to fire apart from the error I made somewhere. But the issue here is that all of this red actually, oh, this is going to zoom out. All of these errors, they actually like might have consumed. Oh, it's because I have 1 day error budgets. They probably like consumed the entirety of that error budget that we set for that period. So that's not good, right? So we actually want to notify someone of that. So this one will actually like stop being notified. This one never notified. So it's like, okay, you have to like think about like which metrics are like the least intrusive. Like if it's like a little blimp, it should notify anyone. Like again, like with this one, which I think is tracking like longer periods than it should be tracking now. But if it's not consuming the SLO at like a pace that is like going to affect your SLO, you shouldn't really page anyone. And that's what this is illustrating, or should be illustrating. And if I hadn't run this whole thing the whole time, you would have seen this one probably go red and this one orange. But I made a mistake of running it. And I'm over time now, so I'm gonna leave it at that.
I'd be interested.
Yeah,
You've got a page of references. I saw, like you have a slide on your last slide.
oh yes. So there's a bunch of like yeah, this is all the SRE book. So like it's a lot of terminology and stuff. Like maybe one thing, oh, the availability table, that's an interesting one. Interesting to look at. This is why you should never have 100% availability, because if you think about 5 nines, you can only tolerate 5 minutes of downtime in an entire year. And it's gonna have burn rates, practical alerting. No. I'll add the burn rate stuff to this as well. I don't see it here now. There's like a nice graph that actually shows it to you. Maybe let's have a look. There we go. So this is like the burn rate, like yeah, how many days would it take to go through this burn rate? But what I'm thinking of showing is this. Yeah, so this is your error rate, like the actual error rate, the factual one. The error rate, like the 1 minute one. The error rate measured over 5 minutes. Error rate measured over 60 minutes. And this is what the alert is trying to show. All of these need to be above this thresholds for the alert to actually fire. The moment it goes down, or like, well, the regular, the actual error rate, we don't really account for because it's only the 5 and 60 minute we care about. But the moment these two are over it, then we're going to fire an alert instead of like firing too quickly, because like this could have dropped at this point, the errors could have gone down and not returned, right? If it would have kept going up, this longer evaluation period would have triggered and be like, okay, this is actually an issue. Someone needs to wake up and think about this now. So I'm gonna add this as well. Wait, alerting on this. No, I didn't add it. So yeah, I know we're massively over time, so I'm not sure if there's time for questions, but you can always ask me. Oh, this is a template. You can always ask me questions on Slack as well.